This is OpenValve, the first 3D printable irrigation valve. Unlike standard timers that water based on a schedule, OpenValve waters based on real soil moisture. You stick the sensor in the soil and it only opens when your plants are actually thirsty. After countless prototypes, I finally arrived at a robust design and successfully tested it in greenhouses, on balconies, and in garden beds, where it worked reliably throughout entire summer seasons. With the simple user interface, you can set how OpenValve waters your plants. A QR code on the battery lid links to practical resources that help you navigate the user interface, like a cheat sheet which shows all possible interactions in just one page, or an interactive manual that mimics the behavior of the real device. To keep the entire system 3D printable, I had to develop a valve that could be manufactured on a standard desktop 3D printer. This was by far the most challenging part of the project, but it also gave OpenValve one of its biggest advantages. Standard irrigation timers cannot handle watering from elevated water containers because the available pressure is too low. OpenValve, by contrast, operates reliably at very low pressure and can even handle water that isn't perfectly clean. But it can also handle water pressures up to 4 bar, allowing it to work with pressurized systems as well. Standard half-inch BSPP threads make it easy to connect common hoses, fittings and adapters. It runs on a standard 9-volt block battery which lasts around 3 months. And it's built to handle pretty much any weather you throw at it. OpenValve is fully open source. All 3D models, PCB files and firmware are freely available on GitHub. If you want to learn how exactly OpenValve works, how to use it and how to install it in your own garden, I made a documentation page that explains everything in great detail. To build your own OpenValve, you can either source the components yourself or alternatively, I offer assembly kits on Lectrons. To complete the build, you'll need the assembly kit, a supported soil moisture sensor and the additional 3D printed ASA parts. The sensor and printed parts can be either added to your assembly kit order or you can source the sensor and print the ASA parts yourself. The build takes around 1 to 2 hours and every step is shown in detail in the assembly guide video. Along with some basic hand tools such as Allen keys and small pliers, you'll need soldering equipment to connect the sensor to the PCB and to install the threaded inserts. The assembly kit does not only make it super easy to build and gives you quality controlled parts, but it also directly supports my work and gives me more resources to continue developing OpenValve.